An attendee is asking, can we answer 3B?
You do a survey now. How do you process it? Well, there's probably two different ways in which it's commonly done. One of them is traverse balancing, where you throw things into a COGO package and maybe use the compass rule. Unfortunately, that doesn't really tell you anything about how well you've coordinated the markers, the parcel corners. If you use a program like GeoLab or some other network adjustment program, then you come up with a measure of the uncertainty in the coordinate values of the parcel as a consequence of the connections. You would have a similar view of what they would have been in the earlier survey, depending on its vintage and if you have some idea of the method that was used. And so you have a difference from two sets of coordinates. You have the measure of a quality of each set of coordinates, so you should then be able to come up with a statistical test to judge the significance. So it's basically looking at, say, the difference in the x-coordinate and its associated standard deviation, which would be a combination of the two uncertainties in x, or easting, and similarly with the northing. Or you could look at it in a simultaneous two-dimensional version where you take the two ellipses and combine them together, so that the difference, which would be a vector in delta E and delta N between the two sets of coordinate values for any one point, whether or not it's within the corresponding two-dimensional confidence region. Now, what was expected there by the request to cite a reference would be, for instance, if you were working in Alberta and doing a resurvey and had to compare the coordinate values, what in the manual of standard practice is there mentioned about judging the quality of them? When can you say that the coordinates that you did are basically the same as the ones that were done before? What's the allowable discrepancy in the, for the differences in coordinate values? So statistically significant would require you to evaluate a quantity and come up with the uncertainty associated with that quantity. And typically, if you do the propagation of standard deviations, then that's at the standard level, and usually testing is done at a higher level, say 95%.
Okay, I have a question. It says SQ2, so I guess the candidate is referring to the study guide.
Yeah, study question 2.
Okay,
that's the one with, yeah.
It says temperature and pressure are measured at each end and are average. So should the answer not be 2 square root 2 for temp in question A?
Okay, so is there anything else that I'll take away this and come back to the study guide. That study guide question doesn't mention that sort of thing. It simply says what would be the limit on the variation of temperature. So that's not suggesting that you would do it at either end, but just simply along the path. Now, in some of the examination questions it has said, for instance, if you have to keep things within, say, 2 parts per million, and that 2 part per million, or the refractive index, is calculated by taking temperature and pressure at each end and averaging it, then you have a factor of root 2 coming into it. So the comment was correct in the context of what would likely have been the question in an exam.
Okay.
Does that make sense?
Okay. I have a question. Let's see.
If there were a question on an exam that was basically asking for you to say how well something was to be measured. It would explain what would be measured and how it would be resulting in the value that has to be determined. This is really just, this particular study question is merely asking whether you can look at the formula for refractivity or refractive index and take the partial derivatives. And the difference between the two parts is that in the first part, it's asking individually how temperature or pressure on its own would affect the refractive index or refractivity, whereas in the second section, part B, it's simultaneously, so you then have to actually consider the two of them together. So that's why a factor of root 2 would come into that one.
Okay, I have a question. I'm not sure I understand it. It says that could you post the answer samples on the website? Well, I think the answer samples from of the study guide are there. But one candidate had asked previously, can CBEPS post the answers to each exam on the website? No, that's against CBEPS policy. We'll never do that.
Now, I can distinguish between answers and solution. And some of these study guide questions are from older examinations. And possibly just giving the actual answer, what the number should be. For instance, in study guide question 1, there's just the answer. There's no explanation other than saying 130 seconds smaller at each corner as to how to calculate it. Would that be within the policy of CBEPS? To give just the answer rather than the solution?
For each exam? Or just a study guide?
Well, for the study guide, they're already there.
Yeah. Well, it's, so far the policy is that for the individual exams, we don't post either the answer or the solution.
Okay.
At this point, anyway.
Okay. Okay. There were forum questions on several other study guide questions, so maybe I'll go to those and then come back to the other study guide questions if there's still time. So as I recall, there was the question 1, which we've just discussed, and also study guide question 12. So SQ12. Now there were other ones, but these are the ones that pertain to this particular collection of topics. And this one is a bit of a crossover. It also pertains to the engineering surveying, but it is dealing with leveling. And so we have a VILD N3, which is a precision tilting level with a 42 power magnification, setting accuracy, which is basically the ability for the instrument to define the level reference as plus or minus 0.2 arc seconds, and the micrometer reading of 0.1, which can be estimated to 0.01. We have 2 benchmarks that are 20 meters apart, so we would set up the instrument halfway between, so the length of sight is 10 meters. What sort of variation on the rod readings would we get at each end? And then propagate that into a height difference. And then this particular question in the context of engineering surveying would be, well, if it's repeated, we have another factor of root 2 coming into it.